This chart illustrates some projections from a model going to 2050 and 2100 under that higher emission scenario, where we've had about 2.5 degrees of warming here by 2050 and around 6 degrees of warming by 2100. It's a much different planet to the one that we live on today, or we've lived on in the past. And the warming continues to be uneven, where in the high Arctic we can get up to 20 to 28 degrees of warming. As we shift the climate, we change the frequency of extreme events, we change the distribution of precipitation, and we change the total amount of energy in the climate system. Now, a small shift in the average is illustrated down here, will, by the nature of the distribution of weather events, have a big effect on extreme events. For instance, hot weather will become much more regular, and we'll have new record spells that we've never had before. We also see effects on geophysical systems. One of the most pronounced so far that we've recorded is on the Arctic sea ice, which seems to be particularly vulnerable to small amounts of temperature change. We're seeing a gradual erosion year by year of the amount of sea ice that's forming or that's remaining in the summer in the Arctic. That was 2007, that's 2008. It's a continued downwards trend, but year-to-year fluctuations. But what you'll note in 2008 is there was more sea ice than in 2007, but the colours represent how old and thick it is. And so there was less old, thick ice in 2008. It was mostly just young, freshly formed ice on the surface. So the volume of ice there continues to decline. We're seeing sea level rise, which comes as a consequence of increases in the heat content of the ocean. As you heat water, it expands. And also, as we're starting to have an effect on large land-based ice sheets, such as Greenland and Antarctica, they are contributing to sea level rise, such that the satellite observations of sea level rise over the last few years have tracked at the top end of our model projections from 5 or 10 years ago. So that's the 75% confidence range for the models, and that's where we are right now. A metre sea level rise, which seems certainly on the cards for this century, will itself have dramatic impacts on coastal communities. This is broken down by land area, population and GDP in the different continents, and you'll note that some areas are particularly affected in terms of land area, such as Asia. And of course there's many people in Asia living around the coast, so they'll be very heavily impacted and be displaced as a result of this sea level change. In terms of total damages, areas like Europe are also very susceptible because they have so much built infrastructure along the coastline. The model projections also predict changes in the distribution of precipitation. Overall, there'll be more water, more snow, but that won't be evenly distributed. You'll tend to get more over the tropics and the polar regions and less over the mid-latitudes. Much of Australia lies in that area, the mid-latitude band, that will get drier. This is a consensus chart from about a dozen climate models that predict that areas such as southern Australia and the Mediterranean region of Europe will become considerably drier this century. Indeed, we're also already seeing over the 20th century an increase in drought, severe drought. This is illustrated in this time series of the Palmer Drought Severity Index that illustrates that areas under deep, sustained drought across the world are increasing, especially in sub-Saharan Africa, parts of Australia and Asia. And indeed, in Australia, after a wet period in the 1970s, we have essentially been in a 30 to 40 year drought, of which we're hitting the worst of it right now. Well, at least we would hope it would be the worst of it. It's certainly, the drought that we're in right now is as bad as the models predict for the next 40 years. We're just hoping we're going to come out of it. Now, let's say we did follow the predictions of the models and say that the average decrease in rainfall in South Australia over the next 40 years was a 30% decline. And these are the rainfall isoheights for South Australia at present, very wet around the Mount Lofty ranges. This is Goyder's line, where you can have regular cropping. This is essentially desert and pastoral land. With a 30% decline in rainfall, you can see that the cropping land has decreased dramatically, less food supply available, and areas that capture much of the water supply for Adelaide, the Mount Lofties, will be considerably drier. We may lose up to 70% of our inflow into our dams in that region. So that is a synergy of climate change and food supply, a topic that I think Michael will also hit upon for other reasons in terms of energy. There's no doubt that climate change will have an uneven impact across the planet. Some areas will be much more heavily impacted than others. Areas that are particularly susceptible, such as much of Asia, are susceptible for a number of reasons. They're buffeted by extreme events naturally, such as hurricanes, typhoons as they're called there. They're sensitive to the timing and regularity of the monsoon, which brings rainfalls at certain events, and climate models, many of them predict that we will cross a tipping point at which it's likely that the monsoon could switch off, and that would have obviously dramatic impacts for agriculture in that region. Areas that supply fresh water through large river systems in India and Pakistan and Bangladesh and China, the Himalaya ice caps, are melting rapidly and would all be lost within the next 50 years, which means the summer flow of these rivers will be gone. And then, of course, as I've said, sea level rise will have a major impact on this area. Southeast Asia is one of those areas that will be particularly hit hard, not only because of its intrinsic vulnerability in terms of its geophysical features, but there's a hell of a lot of people there to be damaged. Agriculture is also likely to be unevenly impacted by climate change. Ironically, the industrialised countries that have so far caused most of the problem are likely to do okay out of a bit of warming, because much of their agriculture is in the far north and is limited, the growing season is limited by temperature, whereas much of the developing world is in tropical areas and they're at their limit already, and any increase in temperature is likely to be damaging. As you increase the CO2, you increase the productivity of plants to accumulate biomass as well, but this is offset by small changes in temperature and extreme events. So the net effect, where most of the people live and where most of the people are bitterly poor, will be where agriculture declines. Now, very briefly, in terms of energy supply, as I said, the problem of climate change is a symptom, a dramatic symptom of the use of the wrong sort of energy. It was the right sort of energy to build an industrial society, but if we wish to retain that industrial society, we must now look to other energy sources. There's vast amounts of energy that come to the Earth every year in the form of solar energy in various forms, wind and wave and direct capture of solar energy. There's also vast stores of energy in nuclear energy, in the concentrated form of energy in the atom. So we have this issue of what sort of energy directions would we take. There are issues with the amount of energy we can extract from renewable sources, not because it's not available, but simply because it's diffuse and intermittent, and so requires, by that definition, huge areas in which to capture sufficient energy and huge technological solutions in terms of storage. There's no reason to suspect these problems are insurmountable, but we're not there yet. We can't power an industrial society at present by renewable energy alone. South Australia is one of those areas that has a wealth of renewable energies that we should be tapping. Many of them are not tapped right now for various non-technical reasons, such as the fact that we haven't got transmission lines to the areas where we could best make use of these energies, and we're not paying the true environmental cost of energy produced by fossil fuels. So South Australia can be a leader in the development of renewable energy. Globally, and I think ultimately in Australia, we will also have to vigorously pursue nuclear energy. For countries such as China and India, these are likely to be the only solution to fixing our energy problems, and if we haven't fixed the energy problems there, then we're not going to fix them. Nuclear power today is not what nuclear power was 40 or 50 years ago. It's made huge strides in development, and I'm happy to talk more about it in question times. Ultimately, I think Australia will end up with 20 or 30 nuclear reactors in the next 50 years as well, supplemented by a large supply of renewable energy, such that we totally replace our dependence on fossil fuels. Because if we don't do that, for many reasons, our modern society is doomed. And I think at that point, I can pass over to Michael Lardelli, who will talk more about other reasons not related to climate, why we must disconnect ourselves from fossil energy. I guess the ultimate message of my talk, therefore, is that we have a large amount of climate change committed. We must manage for that. It will be difficult, especially in terms of agriculture and food supply, and also effects I haven't touched on, such as impacts on natural systems. We must also avoid unmitigated climate change, because that will take us very rapidly to the point where we can no longer